Welcome to this explainer. If you're managing enterprise applications that rely heavily on AI models, you already know the massive headache of rate limits, failing endpoints, and just messy API key management. Well, today, we are fixing that. We're building a highly robust, always-on autonomous AI gateway from the absolute ground up, using Hermes Agent on a Windows Server 2022 VPS. We're going to get deep into the technical weeds here with real deployment commands, so definitely take some notes. Let's dive in.
To get there, we'll follow a pretty strict roadmap. First, the architecture of the AI gateway. 2, Hermes Agent and Codex setup. 3, local API and environment config. 4, CADI HTTPS reverse proxy. 5, automated startup via task scheduler. And finally, 6, YCSP integration and fallback chain.
Section 1. Architecture of the AI gateway. Designing the tech stack. Okay, before we run any commands, we need to map out the abstract layers of our components, right? Knowing how these pieces fit together is an absolute lifesaver for troubleshooting later. So to solve those pain points we talked about, we are leveraging a Windows Server 2022 VPS environment. This server will host the Hermes Agent. You can think of that as the brain of our operation. The intelligence itself is powered by OpenAI Codex, which is our core engine. And finally, all of this is securely routed through a CADI HTTPS reverse proxy. That's our shield, protecting the internal network from the outside world. Separating things out like this means that DNS, TLS, and the AI process can all be diagnosed completely independently.
Section 2. Hermes Agent and Codex setup. Initializing the gateway.
All right, with the architecture locked in, we can start the actual deployment process by initiating the Hermes native Windows installation right in PowerShell. Notice how we're intentionally choosing the full setup option here. By typing 2 instead of just going with the automated quick setup, we get explicit control over our provider, model, and tool configurations. In a corporate environment, relying on automated defaults is just a huge security and stability risk. We absolutely have to know exactly what is running on our server.
Moving into the inference provider list, we explicitly select OpenAI Codex as our primary model engine. This is where we tell Hermes exactly where to source its intelligence for our specific gateway needs. Now, this part beautifully illustrates how a modern OAuth flow should work. Instead of passing static API keys around in plain text, which we all know is a security nightmare, our PowerShell terminal generates a short-lived device code. We simply take that code, drop it right into the browser authorization screen, and securely bind our ChatGPT account directly to the CLI. It's just an incredibly clean, secure handshake. Because this VPS is strictly acting as an API gateway for our web applications, the AI absolutely does not need to interact with the underlying OS. So we intentionally disable high-privileged tools like terminal execution, code execution, and file operations. Applying the principle of least privilege right off the bat like this is exactly what hardens our security posture and keeps the enterprise infrastructure safe.
Section 3. Local API and environment config. Establishing the perimeter.
Okay, the core engine is installed and restricted. Now we need to bind our application strictly to the local host to establish that security perimeter. When we review the .env configuration file, pay close attention to the specific host and port settings. The API server host is set strictly to 127.0.0.1 on port 8642. This is a non-negotiable security measure. By doing this, we ensure the Hermes API process is never exposed directly to the open internet. Every bit of external traffic is going to be forced to pass through our proxy shield first.
But before we introduce complex DNS or TLS layers, we need to validate this local configuration. We do that by executing a simple curl command against our local 8642 health endpoint. Getting that healthy JSON response back ensures the internal Hermes process is fully operational. Rule of thumb: always test locally before you expose globally.
Section 4. CADI HTTPS reverse proxy, building the shield.
Speaking of exposing globally, let's deploy CADI to securely handle that external HTTPS traffic and route it to our local instance. To make our reverse proxy highly resilient, we don't just run it manually. We use these exact service control commands to register CADI as an auto-starting Windows service. And pay special attention to step 2 here. We are actually programming built-in failure recovery. If CADI crashes for any reason, the OS is instructed to automatically restart it. That guarantees our HTTPS shield stays up with absolutely zero manual intervention.
Section 5. Automated startup via task scheduler. Establishing persistence.
Just like the proxy, our AI gateway process itself needs to survive unexpected reboots. A production gateway cannot rely on a human remembering to start a script. By simply executing the Hermes Gateway install command in our terminal, we instruct Hermes to automatically hook into the Windows Task Scheduler. This one single command powerfully shifts Hermes from being an active terminal process that closes when you exit into a persistent background daemon.
When checking the Task Scheduler properties, we need to verify two really vital settings. We mandate that the gateway runs with highest privileges and, crucially, that it runs whether the user is logged on or not. That gives us a true always-on state. Your AI gateway will boot up and serve requests perfectly without anyone ever needing to initiate an active RDP session to the server.
Section 6. WISE COSP Integration and Fallback Chain, the application layer.
Let's move to the final piece of the puzzle and see how this all comes together. We're connecting our secure, persistent backend to the client-facing application layer. Now, why did we build all of this? Well, if your primary model hits a rate limit and throws an HTTP 429 quota error from OpenAI Codex, that single point of failure would normally just crash your web application. Your users get an error screen. In an enterprise environment, that is completely unacceptable, which is exactly why we need a fallback chain. And here is the ultimate payoff. All of that complex back-end terminal work we just did directly powers this clean Eka Sunucu YCP control panel. By pointing YCP to our resilient Hermes gateway, the web application can now seamlessly fall back to secondary providers, like Anthropic or Mistral, if that primary OpenAI route ever fails. The end-user experience is literally zero downtime, and your application remains perfectly stable.
We've covered a ton of ground today. You've seen the complete blueprint for an autonomous, highly resilient AI gateway, from securing the local host, reverse proxying with Caddy, all the way to establishing those intelligent fallback chains. The only question left is, when will you implement this in your own enterprise environment? Thanks for joining me on this explainer, and I highly recommend reviewing these exact configurations as you build out your own AI infrastructure. Catch you next time.